let us understand the counting of onto functions through this example. Subsequently, we will generalize. Suppose A has got 4 elements and say B has got 3 elements. The objective is to count the total number of onto functions. This we are going to count through this technique, so which means number of functions minus number of non-onto functions. So how many functions are there from a set of size 4 to a set of size 3, which is cardinality of B to the power cardinality of A. Now let us count the number of non-onto functions. So the way we are going to count is like this. So the number of functions in which B1 has no pre-image, which means if you look at all such functions, they will be like this. You have A1, A2, A3, A4 and B1, B2, B3. Since B1 has no pre-image, these 4 are mapped only to this. So it may be the case that A1, A2 are mapped to this, A3, A4 are mapped to this, or all of them are mapped to B2, or all of them are mapped to B3, or maybe A1, A2, A3 they are mapped to B2, A4 alone is mapped to B3. But if you look at all those functions, B1 has no pre-image at all. So how many such functions are there? So counting this is equivalent to counting what? Number of functions from this set A1 to A4 to B1 is not in the picture at all, then it is B2, B3. Correct? So which means number of functions from a 4 element set to a 2 element set. What is that? That is 2 power 4. On the similar line, number of functions in which B2 has no pre-image. So we have same number. On the similar line, B3 has no pre-image, same number. Now we will also have functions in which B1 and B2 is not having pre-image. You have A1, A2, A3, A4, B1, B2, B3. So number of functions in which B1 and B2 they both have no pre-images. So which means B1 and B2 is not having a pre-image. So all of this are mapped to B3. How many such functions are possible? That is equivalent to saying a number of functions from A1 to A4 to just B3, which means it is just one function. So 1 power 4, or it is just one function, which is precisely this. Now you need to note this function, the one in which B1 is not having a pre-image and B2 is not having a pre-image, it is counted as part of this. The same function is also counted when we say B1 has no pre-image, because in this function B1 has no pre-image, so this is counted as part of this. The same function is also counted when we say B2 has no pre-image. Fine. So which means this function is counted here. Same function is also counted here. Which means when we look at this count has to be subtracted. So one function is counted at 3 places. One as part of functions in which B1 has no pre-image, again as part of B2 has no pre-image, again as part of both B1 and B2 have no pre-images. So it should be counted only once. So we add these two, so 1 plus 1, 2, and subtract this function. So that 2 minus 1, we get 1, which means this function is counted only once. On the similar line, you say not just B1 and B2, you look at B2, B3, and similarly B1 and B3. So all of this is again just 1. But such functions will be counted as part of these two, then as part of B1 and B3 as well. And that has to be subtracted, which we shall consider next. So if we consolidate what we have discussed, so the number of onto functions, so they are precisely this: functions in which B1 has no pre-image, B2 has no pre-image, B3 has no pre-image. But the same function is counted twice. Which function? Function in which B1 and B2, they both have no pre-images, is being counted once as part of this, because this is not having a pre-image, so this must have been counted as part of this, and this is not having a pre-image, so this must have been counted as part of this. So one function has been counted at 2 places, so that should be subtracted here. So 1 power 4 minus, same thing, B2 and B3. All those functions in which B2 and B3 have no pre-images have been counted twice, subtract. Then B1, B3 counted twice, subtract. So the number of non-onto functions from A1 to A4 to B1 to B3 is precisely this. You can write this in succinct form, which is 3 into 2 power 4 minus 3 into 1 power 4. Further, what is this? This is 3 choose 1. Why? Out of 3 elements, 1 element is not having a pre-image. So how many such possibilities are there? There are 3 of them. And this one I will write it as 3 minus 1 to the power 4 minus this, let me write it as 3 choose 2 times 3 minus 2 to the power 4. What is this? This is telling us out of 3 elements, 1 element is not having pre-image, which means other 2 elements are having pre-images. We are only counting number of functions from 4 element set to 2 element set. So this will tell you number of functions from 4 element set to 1 element is not having a pre-image to 3 minus 1 element set or 2 element set, because 1 element is not having pre-image. So this one tells you that 2 elements are not having pre-images, 2 elements have no pre-images. There are many possibilities, right? It could be B1, B2, or it could be B2, B3, or it could be B1, B3. So in general it is 3 choose 2, which means two of them are not having pre-images. Then all of this should be mapped to only one. And what is left is precisely this. This tells you that number of functions from 4 element set to 3 minus 2 element set. Because two of them are not having pre-images, you are left with only one element. To that set, this has to be mapped. Fine. Now we have counted the number of onto functions. Now with this one can count number of onto functions. Now that's straightforward, which we shall see next. So number of onto functions from A1 to A4 to B1 to B3 is precisely this. Total number of functions minus number of non-onto functions. How much? It is 3 choose 1 times 3 minus 1 to the power 4 minus 3 choose 2 into 3 minus 2 to the power 4. Okay, so this clearly tells you that functions in which exactly one element in the codomain has no pre-image. Functions in which exactly two elements have no pre-images. Because such functions are already counted, I need to subtract. This is precisely the count. Now one can scale this. Suppose you are interested in counting this number of onto functions from say A1 to A5 to say B1 to B4. Then total number of functions from 5 element set to 4 element set is 4 power 5 minus, out of 4 elements in the codomain, there are 5 in the domain, there are 4 in this. One element is not having pre-image, which is 4 choose 1, which means all this is mapped to 3 element set, which is 4 minus 1 to the power 5. And all of this is mapped to 3 of them. Now minus, now you see that functions in which 2 of them are not having pre-images is already counted. So I need to subtract them, which is 4 choose 2 times out of 4, 2 are not having pre-images, so which means you are left with 2. It has to be mapped to this. Now in the process, what has happened, functions which something like B1, B2, B3, 3 elements are not having pre-images, and that you have already removed, you have already counted as part of this when you counted functions in which B1 has no pre-image, B2 has no pre-image, B3 has no pre-image. So 3 times it has been counted. The same function we have subtracted when we looked at B1, B2 is not having pre-image, B2, B3 is not having pre-image, B1, B3 is not having pre-image. So that function is completely removed. Now I should add back that, right? So which means plus 4C3 times 4 minus 3 to the power 5. Functions in which 3 of them are not having pre-images, and which means all of this will be mapped to 1, which is precisely, you have exactly one function, 4 minus 3 to the power 5. So this tells you this count tells you the onto non-onto functions. If you subtract that from this, we get number of onto functions. Fine. Now this can be generalized. Number of onto functions from a1 to say am to b1 to bn. Okay. So then number of functions from an m element set to an n element set is n power m. Okay. And please note, some textbook may use n and m and some textbook may use m and n, but you look at what represents the cardinality of codomain. Cardinality of codomain is n to the power this. Okay. And this many functions are there. In that, you see that n choose 1, exactly one element is not having pre-image, which means you are left with n minus 1 elements. They have to be mapped to this n. Okay. Now n choose 2, alternate, inclusion, exclusion. N choose 2 times n minus 2 to the power m, and plus n choose 3 n minus 3 to the power m. So like that it goes. Fine. Now when do we stop? Out of n choose n minus 1 reason, n minus 1 elements are not having pre-images, so you are left with only one that will be mapped to this. Correct? So we see that out of n elements, n minus 1 elements are not having pre-images, and which means all of this must be mapped to just one element. So how many functions are there? It is 1 power this. Fine. So now you see that total number of functions is n power m minus n choose 1 times all this will tell you that exactly one element is not having pre-image, and exactly two elements are not having pre-images. So like that we alternate. So how long we go? We go up to minus 1 to the power n minus 1 and times n choose n minus 1 times 1 power m. N minus 1 elements are not having pre-images, and all of this is mapped to exactly one element, so you have just one function. Okay. In case the textbook uses a1 to an to b1 to bn, then number of functions is m power n minus m choose 1 into m minus 1 to the power n minus m choose 2 into m minus 2 to the power n, so on up to minus 1 to the power m minus 1 and m choose m minus 1 times 1 power m. Okay, doesn't matter, look at the index and then write it accordingly. Cardinality of b to the power cardinality of a, and one element in codomain has no pre-image, two elements have no pre-images, and three, like that we alternate, which is why this factor is also there. Now you see that this is included, this is excluded, included, excluded. So this technique helps us to get a precise estimate of the number of onto functions. So the idea is to count non-onto functions and subtract that from the total number of functions, which is precisely what we have done through this. And I've given these examples to motivate, to set the stage so that you appreciate how to use pi, not just in this application, in other related applications. And since we were able to build this through examples, the result was coming so naturally that we could appreciate the power of pi through this case study.